In this case,
7 pi over 8. And I mean 14 pi.
I'm hearing lots of stuff here. I'm confused. I think it's 5 pi over 3.
Yeah, that's what I said.
Okay, I thought that's what you said. It's close. I figured that was close to what you were saying. In this case, it's easier to use the negative 60 degrees and then convert that to a value within here. But if you go through it, in this particular case, we get out a value of minus pi over 3. Okay? So when we're solving this particular problem, the answer we get out is minus pi over 3. Now, if you wanted to, you could move your output values anywhere else along our sine graph, but this is the answer that, if you were to plug it into your calculator, this is the answer your calculator would give.
Okay. I think it's going to be in third quadrant.
Third quadrant, what are the values in the third quadrant?
It could be a negative for sine and it could be negative for sine.
Okay, so you get negative for sine, negative for cosine. But what angles are represented in the third quadrant? Angles between pi and 3 pi over 2. So those are outside of the range of values that we want. Okay? So that's why when we're doing the inverse cosine, when we're doing the inverse sine, the angles we get out for the inverse sine are going to be in quadrant 1 and quadrant 4. Okay? What about for the inverse cosine? Problem 2 here. We have a cosine of theta equals -1. There's lots of ways we can do this. Again, just like in the previous problem, we can hit both sides with an inverse cosine or an arc cosine. We take our arc cosine of the cosine of theta. We'll take our arc cosine of -1. Okay. Over here again, these two things annihilate each other. We're left with theta equals our arc cosine of -1. And now I look at my graph and I say, okay, when does the cosine equal -1? When does cosine equal -1? Well, yeah. There's only one place that the inverse cosine equals -1, or that the cosine value is 1, and that's all the way over here. Okay. That's this angle that corresponds with the negative x-axis. What angle is that? That angle is pi. So in this case, we get the angle pi out. Okay. And again, that's part of our range here, so we know where to stop. If I was to change this one slightly, and instead of asking for -1, I was to ask for -0.5. That's an additional problem to do. Alright. Well, where is that angle in terms of my unit circle? Where is the angle that has cosine value equal to -0.5? Which quadrant is that? Not third. It has to be in the second. Okay? Has to be in the second because, again, cosine is the x values. The x values that I get out, or the angle values I get out for the inverse cosine have to be between 0 and pi, which means I have to be in this upper part of my circle. So it's not in quadrant 1, it must be in quadrant 2. And if we were to calculate that, what would we get?
3 pi over 4.
What's that?
3 pi over 4.
Not 3 pi over 4. That's a different, that would be minus square root of 2 over 2. 2 pi over 3. That should be 2 pi over 3. Okay. We're looking over here at an angle. Okay. We're looking for an angle here. Actually, we're looking for this angle. Okay. That angle right there is going to have the same x value as this small angle here. So if we find where the cosine equals a positive half, we can just shift it over here, and then this angle is the same as the little one over here. So subtract that from 2 pi, and that gives us the answer we're looking for. In this case, the 2 pi over 3 is the one we're looking for.
Why did you subtract it from 2 pi over 2 pi?
Sorry, just from pi. That's all right. Why is that always going to be a learning experience with wrong thought? All right, and then the last one we had the inverse tangent one. All right, here we had tangent of theta equals square root of 3. Okay. Rearranging things again, this is arc tan of tan theta equals arctan arctan of square root of 3. Okay. Arctan and tangent don't play well together, they kill each other. Theta is our arctan of square root of 3. Okay? Alright. This is one that you're going to either have to just memorize or you're going to have to be able to just do on the fly. Okay? This square root of 3 value is one of the common angles. It's one of the common angles. Which one is it?
Pi over 3.
Which is it?
Pi over 3.
Pi over 3. Okay? Again, you know that the values of sine and cosine, divide them to get the appropriate tangent value. In this case, we do get out an angle of pi over 3. Is this in the right range? Yeah, it's between minus pi over 2 and pi over 2. So it's in the right range. That's the one that we want. Okay. Alright. Using these inverse trig functions, these arc functions, it really is a matter of how well do you remember the values of sine and cosine. If you remember the values of sine and cosine, doing these arc functions is just taking the value, the output values of the sines, and then assigning them back to their original angles.
Eric, question.
Signal.
I know you just gave me an example, that negative 1/2,
Uh-huh.
wouldn't that be, wouldn't it be 1? Because it's 2 pi over 3, and your range.
Remember which range we're looking at for each of these. The arc cosine function is between 0 and pi.
Oh, okay.
Right? Our cosine one over there is negative between 0 and pi. Yeah. We don't get negatives from the arc cosine. We're always going to get positive angles out from our arc cosine. We're going to get negative angles out for the arc sine and the arc tangent.
Okay. Oh, okay, I see. Okay, cosine. I was thinking,
You're thinking back over here to the domain
no, I was thinking sine.
Oh, you're thinking sine. Okay. It's alright. No problem.
But if, say for instance, it was sine right there,
Okay.
what would we do?
Alright, so let's take a look at that. What if we were asked to find the arc sine of negative 1/2, right? So we have theta equals the arc sine of negative 1/2. First thing we got to do is we want to try to figure out, okay, where does the sine value equal negative 1/2? What quadrant do we need to be in for sine to be negative? Sine is going to be negative down here in quadrant 4. So the answer we get out from this is going to be an angle between 0 and negative pi over 2, right? The angle we get out here is between 0 and negative pi over 2. All right, now I just need to remember back. Okay, shoot, arc sine. Where does sine equal negative 1/2? Let's start with an easier question. Where does sine equal 1/2? When does the sine value equal 1/2? It's in quadrant 1. What angle is it? Remember? It's one of those 3 or 4 common ones. It should happen at pi over 6. Okay? So, if I have a positive pi over 6, I get a sine value of positive 1/2. I want the one down here at negative 1/2. Well, that just means instead of going up by pi over 6, I'm going to go down pi over 6. So this answer would be a negative pi over 6.
Okay.
So, working with these inverse things, it really is a matter of how well do you know the original functions. Okay? Being able to go back and forth between angles and values on our unit circle, and then the other way around, it's a
Yeah,
matter of...
I was thinking it would end up being 2 pi over 3 and we're in the range.
Right, right. And that's, yeah. And the thing that really comes into play here is that we're only looking at specific ranges. Okay? We only have these specific outputs that we can get for each of our inverse functions here. And sometimes we have to fiddle with things to make sure they end up in the right quadrant. But they usually will, unless we do something really wrong, which I hope we don't. All right. That is the end of section 8.6. That does bring us to the end of all of the review material for this course. Now, we are probably going to get into some stuff that will be newer to many of you. Okay? All right. This also brings us to the end of the material that's going to be on your quiz next Thursday. Okay? Your in-class quiz next Thursday stops here, 11.6. Everything from chapter 1 that we talked about will be on that quiz. Not every problem, but every major concept.
We won't have another quiz on course reference, right?
Probably not. Probably not. That just means that the week after that, the quiz is going to be really big. Because there's all the important concepts that we're going to miss by not taking them this week. It's alright, don't worry about it for now.
If we take it on, I don't know if you said this or not, if we take an in-class quiz, do we still have an online quiz?
You won't have it online quiz. That is what we asked, but that's okay.
Okay, I wasn't paying attention.
That's alright. My kids are the same way. Alright, chapter 2.1. So chapter 2.1 is about rates of change and tangent lines. Quoting correctly? Yes, rates of change and tangents to curves. Remember when we started this class, I said that calculus was all about studying how things change. This is sort of our first introduction to sort of the directions that we're going in with this course. Now, we'll start with some simple stuff and build up. So, first thing we're going to look at, we're going to look at free fall. So, in physics class, or in your life experience, you'll notice that when you push something off a cliff, it falls, right? It's not like the cartoons where Wile E. Coyote is running there for 30 seconds and then eventually falls. Now, you push something off a cliff, it falls right away. Okay. Lots of people noticed this before me. One more famous scientist discovered that the rate at which something falls can be given by this equation, where y is the distance traveled and t is the time in seconds. Okay. So this equation right here sort of tells us that if you were to just drop something, it would fall distance-wise. The distance it falls would be given by this equation right here. That's provided you neglect air resistance and all that other physicsy mumbo jumbo, but we'll accept that. Okay. Falling things in the vacuum. All right. Now, if I wanted you to identify the average speed of something, let's take this example, this formula here, and let's calculate the average speed an object dropped of n after 2 seconds. This is what we're going to calculate. We're going to calculate what the average speed of an object dropped is after 2 seconds. Now, this formula here doesn't care about how much the object weighs or anything like that. If it falls without someone giving it an initial downward velocity, if someone just drops it, then we should be able to calculate its average speed after 2 seconds. Okay? How do we do that? How do I calculate speed? Okay. So the average speed is calculated by taking the distance traveled and dividing it by the amount of time it's had to travel that distance. Sometimes you'll often see this written with some other shorthand notation. You'll see it written with a little triangle, distance, over triangle, time. This is mathematical shorthand for change. The triangle here represents change. So change